knowledge. There's 3 problems here. Number 1 is the most simple of them all. I'm not calling it simple or easy, but of them all, number 1 is significantly shorter. Number 2 is not so bad. Number 3 is the worst. Okay, number 3 takes like 5 more steps than the other ones. Okay, so what you're seeing is a progression of difficulty in factoring. Number 1, we talked about just yesterday. It's a quadratic. A equals 1, B is -8, and C is -20. So it's like a little riddle. You need to find numbers that will multiply to the C value, -20, and add to the B value, -8. Remember, multiply to C and add to B. So I'm going to make a list of everything that multiplies to -20. You don't have to. How many people already found the numbers? Okay, you don't have to make a list, but I'm going to. What multiplies to -20? Well, -20 times 1, -10 times 2, -5 times 4. And then I'm going to add those together and just see if any of them get the sum that I want. This is a -19. It doesn't work. Those are not my numbers. This one's -8. That's what I was looking for. These are the numbers I'm going to use. I'll just check this one. Oh, those make -1, so those don't work. So there's only 2 numbers in the list that will work. It's the -10 and the 2. So once you find the numbers, you write out 2 sets of parentheses. You put the letter in. So that's the format. Put the X in. And then you put the numbers that we picked. We picked -10, +2. And that's factoring. That was the last 5 minutes from yesterday. Now, it does say that we should solve it. You can see I hand wrote those zeros in there because I wanted to make sure you remember to solve. Sometimes we just factor, but to solve it, I'll go ahead and I will make both of these equal 0 and just, I call them little mini equations or little baby equations. I'll solve these little mini equations. And now I know what the x-intercepts of this parabola are. This parabola goes through x equals 10 and x equals -2. Who's got a question on that one? Good to go. Okay, so number 2 is a little more complicated. There's a 3 in front. So for number 2, I put this little, I say a doesn't equal 1. A equals 3. And when a doesn't equal 1, when there's a coefficient in front, factoring is more complicated. It's just not as straightforward as this one. So the first thing we should do, does anybody see any way we can deal with that 3? Dominic? Divide everything by 3? Does 105 divide by 3? Get your calculators out. Let's check. I'm not sure. I don't know anything about 105. It sounds like it does? Okay. Well, I didn't know that until I checked in my calculator. So get your calculator out. Check it. So when you're factoring, your calculator is your good friend. Keep it nearby and check your numbers in there. Okay, so I want to make a note here, and I think you should write it down as well. Always check for a GCF, a greatest common factor, a number everything can divide by before beginning. Before beginning the problem. I don't want to say before factoring any other way, but before factoring. Okay, a GCF is a good friend of yours. It makes every number smaller. It makes everything easier. So always look for a GCF when you start. So because 36 and 105 all divide by 3, we can reduce all of our numbers. So if I take a 3 out of 3x squared, it's just x squared. 6 divided by 3 is 2. And what is 105 again? Okay, it works. Okay, good. Okay, now that we've taken that out, now this problem is just like number 1. So now you can factor. Now you have a green light to continue now that that 3 is up there. It should work. Oh, on number 3? So then we're going to do these steps here. So we need to multiply to negative 35. Add to negative 2. 35 is kind of a nice number because it doesn't have a lot of possibilities. Negative 7 times 5. So we found our numbers. Now I can rewrite. My parabola is 3 parentheses x minus 7 parentheses x plus 5. Okay. Now how the problem started, if I put that problem in Desmos and like in the graph, and I put this in Desmos just like this with these parentheses, it's the same graph. We have not really changed anything. It's just rewriting. It's a different representation of the same problem. Last thing we have to do is solve it. So I'll take the 3 out front, make it equal 0, make the x minus 7 equal 0, and make the x plus 5 equal 0. 3 doesn't equal 0, so I'm not going to list that in my answer. Later in the year, there'll be a variable there, and it'll be important. So my intercept is 7, and my other x-intercept for this parabola is negative 5. So now I know 2 points on the graph. Is that good? You got that, Logan? The 7 and the negative 5. That's a brand new lesson. I did not do that yesterday. Yeah. So get in it. Because this one doesn't have a number here. If it had a 2, I would divide everything by 2. But it doesn't. So I can't divide everything. This has a 3 and they all divide by 3. So I did it. Yeah.
Why don't you just get rid of the 3 as soon as you divide? Like, why do you have to take y to put it in front of it?
Technically, you don't. You could just 0 divided by 3 is 0, right? But looking towards the future, we're gonna graph maybe like a cubic function like this, and we'll be looking for 3. And in a case like that, maybe your GCF had an x next to it, and so this is 3x equals 0, and then I have a whole nother point there. So it's just a habit for the future. But your math of dividing everything by 3 and the 3 is gone is okay. Now, if the 3 is gone, the graphs won't match anymore. This graph has a stretch of 3. It's skinny. If you divide both sides by 3 in order to solve, this graph doesn't match anymore. But they do have the same x-intercept. Okay? So that's really good comprehension.
I don't know if that's the same question. Divide everything by 3.
You don't have to write this 3 in front.
Okay.
But I'm letting you know in the future, we'll be taking an x out with the 3, and then we'll be solving it, and it'll be a third intercept on a cubic graph. And then we're also going to do 4, where we take an x squared out with the 3, and it represents 2 x's in. So leading up while dividing by 3 and getting rid of it is totally good algebraically, this is a better habit for future chapter. Just putting it in. So that's a preview for a future skill. So you can do it however you want now. It's totally good. Okay, number 3. Let's take a GCF out. Well, 17 doesn't divide by anything. No, they're 7. They're both prime. So when there's no GCF, you're looking at the worst type of problem to factor. Okay. So number 3 is significantly more work than the other 2. It's so annoying. And unfortunately, we can't just neglect it because it shows up in every single chapter in this book. And you'll factor like this in every math class for the rest of high school. Okay? I have a little handout for you that shows a worked out example. So the steps are here. This is from an Algebra 1 book. Because your Algebra 2 book doesn't show it anymore. It's supposed to be in your Algebra 1 work. So make sure you get this handout today. These are the steps here as well that I'm going to do, but I'm going to do the problem on the screen. So do it with me, but no, I am giving you a handout with steps. 6x squared plus 17x plus 7. Okay, this situation is A is not 1, and there is no GCF. So we'll have to use the grouping method. It's also known as the A times C method. Okay. Step 1. Multiply A and C. What is that? 42. 6 times 7 is 42. Step 2. You want to find numbers that multiply to 42. So because 7 doesn't work, nothing multiplies to 7 and adds to 17. That's a good clue to you that there's an issue. But if I do 6 times 7, that incorporates the 6 into the problem. Find numbers that multiply to 42 and add to 17. So when I hear 42, I only think of 6 times 7. But 6 plus 7 is 13, and that's not going to work. So my tip for you is if you thought of the number 6, then that number also divides by 2 and 3. Okay, so if you can come up with 2 factors, those 2 factors can lead you to other ideas. So now on my calculator, I'm going to try 42 divided by 2 and 42 divided by 3. Colin, what's 42 divided by 3? I don't know. I use a calculator. So this would be 14. Yeah, see, that's not, when we learn our multiplication tables, we don't learn 14. So that didn't come to us. So we're using a calculator, okay? And 3 plus 14 makes 17. That's what we were hoping to find. We found our numbers. What do we do with them? Okay, step 3. You're going to rewrite the original problem. You're changing the B value to the numbers that work in the previous step. Numbers. So what was the original problem? It was 6x squared. I'm not going to write 17. 17's out. It didn't work. Don't like it. Instead, I'm going to write the 3x and the 14 that I just picked. Have I changed the problem? No. If I combine like terms, I get exactly what I started with. Okay? What I did is I turned it into a 4-term problem, and I found numbers that are going to work for me. So, the great thing about a 4-term problem is that now you can factor by grouping. You're going to group in GCF. So I'm going to focus just on these first two. And take a GCF out. So literally ignore the 14 and the 7. What's the GCF of just those two? Take it out and rewrite it. They both divide by 3. They both divide by 3. They also both have an x. 6 divided by 3 is 2. 3x divided by 3x is 1. If you can't do that, you need to come into school. Okay, if you don't know what I just did to take a GCF out, you need to come after school. You'll never figure this out. Okay. A GCF is the opposite of distribution. 3x times 2x is 6x squared. 3x times 1 is 3x, right? So when I factor those out, that's what I have left. Now I'm going to do it again with the second group. So I'll cover up the first two. And what's the GCF of 14x and 7? Take a 7 and put it in front. If you take a 7 out, 14 divided by 7 is 2. 7 divided by 7 is 1. Okay? Now, there's a little green light here if your parentheses match. The parentheses must match. If you didn't get the same, if you ended up with twins right here and here, then you've done something wrong. Go back to the start. Those parentheses, they're the same thing. Look at it. Isn't that wild? Oh, isn't that a word? Like I just, wow. Those came out the same. If you do it right, that's how it should happen. So, once your parentheses match, you bring the GCS together. So that's 3x and the 7, and you keep one of the matching set. That's my best handwriting. Okay. And then make them equal 0 and solve it. Probably some of you are wondering where did I get the 3x and the 7 from? Subtract 7. 3x is negative 7 divided by 3. So look at this answer. Negative 7 over 3. What is that? 2.3 or something?
Yeah, repeating.
It's a lame decimal. So the reason we have a decimal answer is because we had a complicated problem. Okay? These ones, the easy ones, get you regular numbers, integers. That longer process is because the answer is a fraction. It's more difficult to come up with. So our intercepts are negative 1/2 and negative 7 over 3. More complicated answers, and that's because of that number in front. Who's got a question? Okay, so now you have a Bellward quiz, but when you turn it in, you'll get this handout, and the handout shows a worked out problem and explains it like a textbook would, and then there's some practice problems here for you. So you got a separate piece of paper for your Bellward quiz. Yeah. Number one, the ninth is actually a Saturday, so it's supposed to say the 8th on it. Please not write on the green paper. Number one should say 9, 8. Yeah, just a minute. Oh, no. They're on my desk up there.
Only one for this week. Yes.
So the number one, so I think it's 3 forms of that, right? Right, the first one.
Yeah, one. The first one.
So number 8 says just numbers. Am I right?
You could just write the answer.